This video's main goal is to break down the outgoing systems tests created in the shop for each orbit that gets shipped to the field. The outgoing systems test, better known as the OST, is unique to each and every orbit. So each orbit that goes to the field has its own OST sheet. This OST sheet is basically a breakdown of all the information you need that was programmed to that tool or how the tool is set up that you need to run the tool in the field. Some of the information provided is information needed to set up your hydraulics. So what restrictor you're going to use is based on critical measurements in your OST. Information you need to set up your downlinking sheet, whether or not your tool has real-time capabilities, the initial steerings programmed into your tool, what your internal battery's expiration date is, and very important critical flow rates needed to operate the tool. So to retrieve your OST is a two-step process. The first step is to properly identify the orbit shipped to your location. This can be achieved by locating two serial numbers stamped on the tool. The first serial number being the bias unit. This is located on a recessed groove between two pads. The second serial number is for the control collar. This is stamped on a flat plate located between the two anchor bolts. So once you're equipped with your two serial numbers, you can go to the link provided at the top of the page. This is the SharePoint where each and every OST is uploaded from the shop. Okay, once you get to the SharePoint site, I'm using Internet Explorer, and I can simply hit Control F to initiate my search function, and then with my search function at the top I can type in my bias unit serial number, so 51. You can see it highlights the one that I want. Simply click the link, and once you get to that link, just hit download. That way you can save this OST sheet in your job folders for archiving. So once you have your OST downloaded, you will see that it's a 10-page document basically split into 4 different sections. We'll go through each section and highlight the critical details you need to acknowledge. So the first section is your collar loadout sheet. You can see the header of this section has a client and a rig that the tool was built for. Don't be alarmed if this doesn't match your particular client and rig. It just means that this tool more than likely came from another location, which just reiterates the fact that you need to check this OST to make sure that your tool is fit for your job. And you want to do this as far as advanced as you can in case there's some problem with the setup that you can communicate to your coordinator and get the correct tool out there. Okay, so starting from the top, you'll have the hole size that your tool is set up for. You can check this with the no-go ring across the pads and stabilizers on the tool. Very critical here is your two serial numbers that you just got off of the tool, which is your bias unit and control collar serial number. As previously mentioned, each OST is unique to each physical tool sent to location. So by confirming these two serial numbers, you know that all the information provided was for this particular tool. Okay, the third serial number that you'll confirm later on through this workshop is the control unit serial number. So this is basically the brains inside your tool, and you just confirm this is correct by getting these two serial numbers off of the tool. Okay, the next subject of interest is these 6 values right here is for your ball sleeve radial gap measurements. These are done in the shop, and this is the only place that you can retrieve these 6 values. These values are for setting up your PD squared. The next section of interest in this OST is your tool configuration report. This starts with a header section for job information. The next section that we really want to look at is tool information. So here you will find information you need to set up your downlinking sheet. So your tool manufacturing code, this PDCU GA, that's the type of control unit I have in my tool. I need this along with the software or firmware version set up in my tool. With these two pieces of information, you will use to set up your downlinking sheet. Next is the tool configuration parameters. This is a table with three main columns that we want to look at. The first column is the name of the parameter. Second is the value, so this is specific to what the tool programmed. And the third column of interest is the report name. So this is basically a breakdown of the options that the shop can configure for each tool. So starting at the top, you'll see this is a 475 collar size. Next is your downlink bit period. So it is able to receive 18-second bit period flow downlinks. If you wanted to send a 36-second flow downlink, you would have to send a dedicated downlink to switch it from 18 to 36. And then all downlinks prior to that can be sent with a 36-second bit period. The next is your drilling cycle. This is a default 3 minutes or 180 seconds. Then your next three rows are basically how the steering is set up in your tool. So desired steering mode has two options, build and turn or power V. This one is set up for build and turn as depicted by this 0 value. Give your desired tool face, which is 0, and desired steering ratio. This is also 0. So since these three rows are 0, basically I know this tool is set up in neutral mode. And then the desired tool face is 2, so that would be gravity. Next is my ROP index. There's two options here, a 0 or a 1. A 0 is for slower expected ROP from 20 to 100 feet an hour. And then if there was a 1 in this box, it would be set up for the fast option, which is 80 to 400 foot an hour. So this one is set up for the slower ROP, which is 20 to 100. And just a side note here, your ROP index is important to set up before you put the tool in ink hold or HIA, as in this can help mitigate tangent or lateral oscillations depending on how fast you're drilling. So you want to set this up prior to engaging in ink hold or HIA. The next is your drop rate. This just assumes a 15% drop rate even if you are achieving your inclination target. You have your slew rate, which for orbits is 4 RPMs. Your slew mode can be one of two options, 0 or 1. For orbit, this should always be 0 because it is rotating absolute to Earth and not the collar. Your mule shoe angle, I don't care what this number is as long as it's not 0. So 0 would indicate that the tool's mule shoe angle has not been set up. So anything other than 0, we're good to go. You have your tool face shift angle. This is dedicated for what steering unit you have. So an orbit should always be 60. And that's what we have here. Tool type also dependent on the steering unit. So an orbit will always be set up with 3. Next is your uplink type. So this is based on whether you have real-time capabilities or not. Depending on what your uplink type is, there needs to be a dedicated receiver in your MWD tool that it's compatible with. So you can see from this MWD real-time matrix what's set up for what. So the next area of interest is this feature collar downlink. A 1 indicates that this tool can receive collar downlinks. And then HIA. So a 1 indicates that it is able to receive a hold inclination in azimuth mode. So 0 here would indicate that your tool would not be capable of HIA. The last part of this section is your calibration coefficients. So we're not going to go into too much detail here other than the fact that your DNI and gamma calibration is depicted by these first 7 rows. Okay, so the only thing I want to look at here is that none of these dates say January 1st, 1970, as in this is the default of this tool software. So as long as you don't have a date that goes back to 1970, everything's good to go here. The third section of interest for this OST is your field information sheet. So this has some information that we've already confirmed, but there's also some things on here that you can only find on this section. First, you have your control unit serial number. So you want to make sure this matches that top sheet. The first area of concern here is your battery expiration date. So each orbit has an internal battery. Even though it is powered by the flow, when you shut the pumps down, this battery helps keep your settings for the next time it's powered up by the flow. So the main thing you want to focus on here is that this date has not been reached yet. So by the time you pick it up or by the time you plan on being at TD, you want to make sure you're within the expiration date. If it's close, you want coordinator approval to run this tool. Your firmware set up for your downlinking sheet. Your steering mode, whether it's in neutral or power V, so you can confirm the earlier settings. Next two are for real-time transmission. So it's got an extended clips in here and an iLink board version 28. This is the only place you can see if your tool is actually set up for gamma or not. So this says yes. So we are able, if the client is expecting gamma ray readings from the power drive, we're good to go. If this said no here and you know the client needed gamma, this would be a good time to communicate that there is no gamma set up to your coordinator and make sure that's okay. So the last section of interest for this OST, and arguably the most critical, is your power drive flow loop analysis. So this is particular to each tool. So you want to confirm that this is the correct control unit serial number for what matches your loadout sheet. And in essence, what is going on here is each control unit is run through a flow loop analysis. So based on this analysis, it outputs your maximum drilling flow rate and your minimum drilling flow rate. Also the minimum tool turn-on flow rate. So you can see these 3 numbers here are the values in water. So what you want to use is this next section where they convert it for the particular mud weight you plan to see for this job. So for this one, my maximum drilling flow rate for 11.5 pound mud is 326 and my minimum drilling flow rate is 189. So basically this is my operating envelope for flows. I don't want to go above this. I risk damaging the tool, and going below this number would risk not anticipated steering capabilities, and also this flow range is the optimal rate I need to clean my torquers. So if you go below this flow rate of 189 gallons per minute, you're at risk of torquer jamming. The last number on here is your minimum tool turn-on flow rate. So this basically says anything above this flow the tool should turn on, but it's not recommended to operate around this range because, as mentioned previously, it's not optimal cleaning flow rate for your torquers. The only thing this number matters for is while you're downlinking, your low state, you don't want to drop below this 133 gallons per minute for this tool, as in the tool will turn off and potentially drop your downlink. The last thing to note here is if you are not within a plus or minus a half pound of this mud weight, you need to calculate your own flow rates, and you can do that on the next page in this mud weight flow rate domain. Okay, so the red line here is your minimum drilling flow rate, and this vertical black line is your max drilling flow rate. So for instance, let's say we're anticipating 14-pound mud. So we would come to the y-axis, draw a line across our 14, and then we see this intersects this red line here, drop down to the x-axis. You can see 150, 160, 170, so it's just under 180. So we'll say our minimum drilling flow rate is 178. And then we intersect the max drilling flow rate here. So 310, 320. So we can say our maximum drilling flow rate is 325 gallons per minute. So this is now our new operating envelope for 14-pound mud. Alright, so this wraps up the breakdown of the OST sheet for each orbit. A few key points I want you to take away from this video is, remember, check out your OST as soon as possible. With all this critical information, it gives you time, if the tool is not set up or fit for duty for this job, to get one out there that is. Also remember, each OST is unique to each tool. So your flow loop analysis, what software, firmware is particular to this tool. So you want to make sure and confirm your two bias unit and control collar serial numbers match what's printed on your OST. Remember, this is critical for setting up your hydraulics and PD squared and your downlinking version. Also, you want to confirm the anticipated parameters for the run. So what mud weight you plan on running, anticipated flow ranges. Do these flow ranges for this tool match your MWD flow ranges? And other things like real-time comms, or whether or not you need gamma ray. So remember, check this sheet out, confirm the critical points, and hopefully you will be fit for duty.